This is the 2013 differential equations question. Starting off on 10a, okay, and it goes, if x squared times dy dx minus 7 equals 0 and y equals 1 when x equals 7, find the value of y when x equals 14. What we'll do first and foremost, bring the 7 out of your side, we get x squared dy dx equals 7. What we'll then do after that is bring the x's and the dx's to one side, so we're going to get dy equals, we're going to get 7 over x squared dx. We can use a power rule there to change down to 7x to the minus 2 dx equals dy. What we'll next do is we'll next do limits and pair them off. So put the integration sign on both sides. And what we can do is we know that when y is 1, x is 7. And then we know that we want x to be 14 when we want to find out the value of y. So we're pairing off the limits. Upon completion of that, we're now going to integrate both sides, and what we're going to get is y bracket, when you integrate like the number 1, you get y. So you get y bracket y is to 1. You're going to integrate 7x to the minus 2. Now you don't have to worry about the 7 to begin with. So when you're integrating, you take 1 away from the new power is going to be x to the minus 1. Okay? And then we got to multiply by the new power, which is 7 times minus 1, so it's going to be minus 7x to the minus 1. So when we differentiate it, you'll get back to minus 7x to the minus 2. Okay, so it's going to be minus 7x to the minus 1 from 14 to 7. So what we're going to do next is going to use the limits on both sides. So we're going to get y minus 1 equals, minus 7 minus 14 to the power of minus 1 minus bracket minus 7 by 7 to the minus 1. Put that into the calculator, that's 14. So what we're going to get, minus 7 over 14 minus 14 plus 7. So that's going to be a plus, and that's going to be 7 over 7, isn't it? So we should get a 1 plus 1. Yeah.
It's not minus 14.
Oh, it's plus 14. Oh, excuse me, yeah. So it's going to be minus 7 over plus 14, which is, oh, that's minus a half. I got you. So that is going to be minus a half. Minus a half plus a half is a half. Bring it over to 1. And we're going to get y equals 1.5. Okay. 10 marks going for that question. 5 marks for your integral and 5 marks for your y value. Okay, moving on. A particle starts from rest at O at a time t equals 0. It then travels along a straight line with acceleration 4t minus 6 meters per second squared, where t is the time measured from the instant when the particle is at O. Find its velocity and its distance from O at time t equals 3. Okay, so what we know is acceleration is dv dt. And dv dt equals 24t minus 16. This is a good matchup because we have dt in terms of t, and so there's only one letter and it matches. Okay. Now once we find out it'll answer one of our questions. It will find out the velocity for us, but it won't find out the distance. So we'll answer the velocity part first, the distance part second. So cross multiply there, and we're going to get the integral of dv equals the integral of 24t minus 16, and you're going to bring the dt up here. Now you've got to match limits, okay? To match limits, straight line. Okay, so at t equals 0, when t equals 0, v equals 0. Okay, because it's not moving. It starts from rest, keyword rest. And then what we have to find out is when we have to find out the velocity when the time is 3. So v is the upper limit and 3 is the upper limit for t. We're now going to integrate, and what we're going to get is v from v to 0 ends up to be 12t squared minus 16t from 3 to 0. And then what we can get here is going to be 12 times 3 squared minus 16 times 3. The second limit doesn't matter, and that's going to be v minus 0. And then we're going to get v equals 9. It's going to be 108 minus 48, which is 60 meters per second, and that was worth 5 marks. And that's to minus 1. Okay. Now, there's something else that's hidden in this part here, okay? Now, distance, okay? Yeah. Phi is the SDT. Does everyone understand that? The SDT is phi. So, when you change the distance, to link distance to acceleration, you first have to isolate v on its own. Upon isolation of v, then you can find out what the SDT is. Now we integrated this here, okay? But if we didn't use 3, and instead of 3 we used t, what we would have found out then was that v equals what's in this integral here. So phi equals 12t squared minus 16t, 2013 differential equations. Okay? And we know about phi is defined as the SDT. And the SDT therefore is 12t squared minus 16t. We can then cross multiply and we get ds equals 12t squared minus 16t, and then we've got it times dt. And then what we can do next is we can just integrate them. Okay, so when we're integrating these, we've got to be aware of, we're looking for the distance. So we're looking for distance when at time 3. Okay? So, what we know is that the upper limit is 3, and that's matched off with s. The lower limit is 0, and you didn't travel any distance at 0. We're now going to integrate both sides, and we're going to get s from s to 0. Ends up to be, so when we integrate this, what we're going to have to get is 4t cubed, and 4t cubed minus 8t squared, and this is from 3 to 0. Then we're going to get is s minus 0, ends up to be 4 times 3 cubed minus 8 times 3 squared. 3 cubed being 27, 27 times 4. 108? Yeah, so it's going to be 108 minus 72, which is 36 meters. Okay, and that complete question went for 30, was it 30? 1, 2, a double 3. Oh, sorry, went for 15 marks. Okay, 15 marks for that question there. Any questions? Okay, move on. Part C.
There's part 2.
Oh, so part 2.
Yeah.
Oh, excuse me. Part 2. The value of t when the speed of the particle is 80 ms to the minus 1. Okay, well that's not too bad because the velocity equation is 12t squared minus 16t. Okay, and what we can say here is that let the velocity be equal to 80. Okay, and then we get 12t squared minus 16t minus 80 equals 0. We're going to divide by 4, and what we get is 3t squared minus 4t minus 20 equals 0. You're going to do the I do this a different way. I use the reference number method. So you just solve that quadratic equation, and I'll get this now. 6 and 10. So it's going to be 3t squared minus 10t plus 6t minus 20 equals 0. Then I'm going to get t into 3t minus 10 plus 2 into 3t minus 10. And then what I'm going to get here is I'm going to get t equals minus 2, which is not possible. And the other one will be 10 over 3. Okay, so 3t equals 10, t equals 10 over 3 seconds, or t equals minus 2. It can't be minus 2 because it has to be positive. Alright guys, so that is 10 over 3 for that, okay? So now we're on differentials part C on 2013. Okay? Water flows from a tank at a rate proportional to the volume of water. The key thing there is proportional, not equal. Okay? Of the water or volume remaining in the tank. The tank is initially full and is full, and after 1 hour is half full. How many more minutes will it be 1/5 full? So the VDT represents the change in volume with time. The change in volume with respect to time is K times volume, where K is a constant. It's related to its volume. But you got to remember, volume is decreasing, which makes it minus KV. Okay, part after that then is, okay, we got to rearrange this so we get 1 over V to V equals minus K dt. Okay, now that this is done, what we're going to get is we're going to have to get we're going to integrate this here, okay? So we know at 1 hour, we know that it's, I want to do this the other way around. I wouldn't have done it that way, I would have done it the other way around. What I would have done is, actually no, we'll do 1 and 0, it's grand. 1 and 0. Okay, after 1 hour, it's a half full, and at 0, it's V full. Okay, we integrate, and what we get is 1 over V integrates to ln V, from a half V to V. The next part then is going to be minus KT from 1 to 0. Then we're going to integrate this, and what we're going to get is ln V, ln half V ln a half V minus ln V equals minus KT, minus K times 1, which is minus K. Now, what we do is multiply both sides by minus 1, and we'll get is ln V minus ln a half V equals plus K. Now the log rule, log x minus log y is log x over y. Okay, so what we get here is what we get here is log V over half V, so ln V over half V equals K, and that means K equals ln 2, because the V's will cancel and 1 divided by half is 2. Okay, so more minutes will it be a 5th full. So what we can go is back up to the part up here at the top, okay? And what we can say is that we can find out ln V. So we can use ln V, and we can change this limit to V over 5. And then we can change the number 1 to T. We can then change K to ln 2, which is a constant, and then we can integrate both sides like we did last time. Now, integrating both sides. This time we still get ln v, and we're going to get ln2 times t. ln2 times t. And this time it's going to be from t to 0. And then that's a fifth v this time, because it's a fifth full. And then you put this into the calculator, so you're going to get ln v over 5 minus ln v equals minus ln 2 multiplied by t. And t is still t there. Then we're going to put this into, multiply both sides by minus 1 like we did last time, so it's ln v minus ln v over 5 equals t times ln 2. And then when we do the log rule for ln v minus ln v over 5, it's going to be ln v, to take away v over 5, equals t ln 2. And then it's going to be ln 5 equals t ln 2. Then t is going to be ln 5 divided by ln 2. So log 5 divided by log 2, which is going to be ln 5 divided by ln 2. And what we get here is 2.32. So 2 equals 2.32. Now that means it takes 2.32 hours in total. That's not what we're asked. We're asked about how many additional minutes it was. So we got to take away 1. And when we take away 1, what's it? 322. Okay, so take away 1, and it's going to be 1.322 hours. Now we're asked to convert that into hours into minutes. So take away 1, multiply with 60. 79.32 minutes. So 79.32 minutes. Okay.